Hello students, welcome to mathematics class. So in this class let us discuss some more examples on the expansion of Lorentz and Taylor series. The first example of this video is f of z equal to z square minus 1 divided by z plus 2 into z plus 3 in the regions mod z less than 2 and 2 less than mod z less than 3 mod z greater than 3. So here this is the given function and f of z equal to that z square minus 1. Now multiply the denominator, that is z square plus 5z plus 6. Now here the degree of the variable is same in both numerator and denominator, so it means that it is an improper fraction. So therefore whenever we need to solve or we need to expand the series, the given function must be a proper fraction. Whenever it is improper, first we need to reduce that to proper fraction and then proceed to expand. So here by usual division, that is z square plus 5z plus 6 is the divisor and this z square minus 1 is the dividend and this is the quotient and remainder, right. Now multiplying by 1 to this divisor we get the same thing, z square plus 5z plus 6, then by subtracting minus 5z minus 7. Then by using the division algorithm, a is equal to bq plus r. So here a equal to z square minus 1 and b is the z square plus 5z plus 6, q equal to 1 plus remainder is minus 5z minus 7. So therefore now substitute this in the f of z, z square minus 1 equal to this value. Then that is that f of z becomes 1 minus 5z plus 7 divided by z plus 2 into z plus 3, because z square minus 1 is equal to this one and separately divide the denominator, then z square minus 5z plus 6 is divided by z square minus 5z plus 6, that is 1, and here by taking negative sign common, that is minus 5z plus 7 divided by that one z square plus 5z plus 6, and that is equal to z plus 2 into z plus 3. The same thing here I have written, and then this becomes f of z. Now consider this only, 5z plus 7 divided by z plus 2 into z plus 3. Now by using partial fraction, a divided by z plus 2, b by z plus 3. So here a equal to minus 3 and b is equal to 8. Then 5z plus 7 divided by z plus 2 z plus 3 is equal to minus 3 by z plus 2 and plus 8 by z plus 3. Then f of z becomes 1 minus this value, because 1 minus 5z plus 7 divided by this, then this is equal to minus 3 by z plus 2 and 8 by z plus 3. By multiplying this minus, that becomes plus and this plus become minus. Then go through the regions. The first region is mod z less than 2. So here f of z equal to 1 plus 3 by z plus 2 minus 8 by z plus 3. The region is mod z less than 2. So we know that whenever z is less than some constant, we need to take the constant which is present in that factor outside, and if z is greater, then take the z value outside. So therefore now f of z equal to 1 plus 3 divided by, here the constant is 2, so therefore it is 2 into 1 plus z by 2 minus 8 into, here the constant is 3, so 1 plus z by 3, then it is equal to 1 plus 3 by 2, 1 plus z by 2 whole power minus 1 minus 8 by 3, 1 plus z by 3 whole power minus 1. Then it is 1 plus 3 by 2. So let us write this expansion in the summation form, that is summation over n equal to 0 to infinity z by 2 whole power n, because it is 1 plus x form. So whatever present in the place of x, that x must be considered in the summation except constants. So therefore z by 2 whole power n minus 8 by 3 summation over n equal to 0 to infinity z by 3 whole power n. So this is the expansion of the function in the region mod z less than 2. So here this is the Taylor series because there is no z in the denominator. If any z present in the denominator, then that will be the Lorentz expansion. Now the second region is 2 less than mod z less than 3. By splitting this we get 2 less than mod z and mod z less than 3. Here we have two inequalities. The first inequality gives mod z is greater, means in the factor where 2 is present we need to take the z outside, and here 3 is greater and here we need to take that 3 outside from the factor. So therefore f of z is 1 plus 3 divided by z plus 2 minus 8 divided by z plus 3. So 1 is constant as it is, then 3 divided by, here z plus 2 is there and 2 is less than z. It means that we need to take that z outside, then it is 1 plus 2 by z minus 8. Here 3 is greater, that greater value must be outside. 3 into 1 plus z by 3. Then it is equal to 1 plus 3 by z, 1 plus 2 by z whole power minus 1 and 8 by 3, 1 plus z by 3 whole power minus 1. Then write in the summation form, that is 1 plus 3 by z, here summation over n equal to 0 to infinity 2 by z whole power n minus 8 by 3 summation over n equal to 0 to infinity z by 3 whole power whole power n. So this is the Lorentz expansion, because in the first expansion z is in denominator, means it has negative powers. Whenever the z has negative powers, then that is nothing but Lorentz expansion. Then here the third region is mod z greater than 3. There is only one equality and z is greater, so therefore you need to take that z common from both the factors. So here f of z is equal to 1 plus 3 divided by z plus 2 minus 8 divided by z plus 3, and region is mod z greater than 3. So therefore that f of z becomes 1 plus 3 divided, greater is z, so therefore z into 1 plus 2 by z minus 8, here also z into 1 plus 3 by z, then it is equal to 1 plus 3 by z 1 plus 2 by z whole power minus 1 minus 8 by z into 1 plus 3 by z whole power minus 1, then it is 1 plus 3 by z summation over n equal to 0 to infinity 2 by z whole power n minus 8 by z summation over n equal to 0 to infinity 3 by z whole power n. So therefore this is the way to expand that Lorentz and Taylor series. So here only important thing is taking that common term. So in the inequality which is greater, that value must be taken outside from that factor, and if two inequalities are given, depending on the inequality we need to take the factors, we need to take the common term from the corresponding factors, because here in the second one 2 less than mod z and z less than 3, right. So, in the first inequality z is greater, and that is only when 2 is less than mod z. So, means whenever 2 is present, at that case only we are taking z common, and in the remaining all we need to take that 3 common, that is only important thing. So, these are the expansions of the Taylor's and Lorentz series in the corresponding regions. Next example, expand f of z equal to z plus 3 divided by z into z square minus z minus 2 in the regions mod z less than 1, 1 less than mod z less than 2 and mod z greater than 2. So, here the given function is not in the standard form, means in denominator there are no linear factors of z. So, first we need to find the factors, then by using the partial fraction we need to separate the fractions, then expand the series. So, here the function given is z plus 3 divided by z into z square minus z minus 2, and the factors of this quadratic equation are z plus 2 and z minus, so z plus 1 and z minus 2. Then by using partial fraction a by z, b by z plus 1, c by z minus 2, by using the partial fraction a equal to minus 3, b equal to 1 and c equal to 2. Then here f of z becomes a by z, that is minus 3 by z, b equal to 1, 1 by z plus 1, c equal to 2, 2 by z minus 2. So, this is the given function now, and let us expand these function in the regions given. So, the first region is mod z less than 1, means 1 is the greater value, it means that we need to take the constant term in that factor outside. So, now f of z equal to minus 3 by z. So, in here this is not the linear factor of z, it is only, or it is not in the form of z minus a. So, therefore, we need to put this as it is, plus 1 divided by z plus 1 plus 2 divided by z minus 2, and here minus 3 by z as it is plus. Now, already it is in the standard form only, but here we need to write this as 1 plus z form, that is 1 plus x, and plus 2 divided by, here constant thing is minus 2, so minus 2 outside, 1 minus z by 2, and here 2 and 2 get cancelled, it is minus 3 by z plus 1 plus z whole power minus 1 plus 1 minus z by 2 whole power minus 1, then minus 3 by z as it is, plus by using the summation form it is summation over n equal to 0 to infinity z power n plus summation over n equal to 0 to infinity z by 2 whole power n. That is the expansion of the function in the first region. And for the second region is 1 less than mod z less than 2, it implies that 1 less than mod z and mod z less than 2. In the first inequality z is greater, and in the second inequality 2 is greater, means in these two factors, here z plus 1 and z minus 2, wherever 1 is present in that factor we need to take z outside, and whenever 2 is there we need to take 2 outside. So, here f of z is equal to minus 3 by z plus 1 by z plus 1 plus 2 by z minus 2, then it is minus 3 by z plus, here z is common because z is greater than 1. So, z into 1 plus 1 by z plus 2, here 2 means constant thing is common, that is minus 2 into 1 minus z by 2. So, 2 to get cancelled, Then here this is equal to minus 3 by z plus 1 by z into 1 plus 1 by z whole power minus 1. Sorry, it is here minus 1 minus z by 2 whole power minus 1. So here also this is minus in the first region. So whenever we have negative sign, in that case we need to write minus 1 whole power n. So here sorry, this plus becomes minus, and this is 1 minus x whole power minus 1. So whenever minus sign is there, all the terms will be positive, but when x plus 1 plus x is there, there we should get a alternative plus sign minus. So therefore here we need to write minus 1 whole power n in case of plus. So therefore in the previous examples also, mostly I have forgotten to tell that whenever 1 plus z form is there, while writing the summation form of this one, write this as summation over n equal to 0 to infinity minus 1 whole power n z power n. Remember that. Mostly in the previous examples also that I have mistaken. So please do the correction that whenever the factor is of the form 1 plus z, then add there minus 1 whole power n, because we know that expansion of 1 plus x whole power minus 1 is, here it is minus 1, 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube plus x power 4 and minus x power 5 and so on up to infinity. So here alternatively plus and minus are there. So therefore first, that's why we are adding that minus 1 whole power n in that case, that is 1 plus z whole power minus 1. So therefore here minus 3 by z plus summation over n equal to 0 to infinity z power n into minus 1 whole power n minus, because 2 by minus 2 is there, so that's why this becomes minus, then summation over n equal to 0 to infinity z by 2 whole power n. If it is 1 minus x whole power minus 1, no need to write minus 1 whole power n. And if it is of the form 1 plus x whole power minus 1, in that case write minus 1 whole power n. That is the only correction. And now here it is minus 3 by z plus 1 by z into, again here summation over n equal to 0 to infinity, it is of the form 1 plus x. So therefore minus 1 whole power n 1 by z whole power n minus, this is 1 minus x, no problem, summation over n equal to 0 to infinity z by 2 whole power n. That is the expansion of the series in the given region. And the third region is mod z greater than 2 or 2 is less than mod z. So here only one equality is given and mod z is greater, so therefore from each factor we need to take that z common. So therefore f of z equal to minus 3 by z plus 1 by z plus 1 plus 2 by z minus 2. Then this is equal to minus 3 by z plus 1 by z into 1 plus 1 by z plus 2 by z into 1 minus 2 by z. Since z is greater, we are taking that z common from each factor. Then it is minus 3 by z plus 1 by z into 1 plus 1 by z whole power minus 1 plus 2 by z into 1 minus 2 by z whole power minus 1. So minus 3 by z, 1 by z, summation over n equal to 0 to infinity. Here 1 plus x, therefore minus 1 whole power n, 1 by z whole power n plus 2 by z, summation over n equal to 0 to infinity. This is 2 by z whole power n, because it is of the form 1 minus x whole power minus 1. So whenever we have 1 minus x whole power minus 1, no need to write that minus 1 whole power n, or if it is of the form 1 plus x whole power minus 1, in that case you should remember that we have to write that minus 1 whole power n. Next example, expand 1 divided by z into z square minus 3z plus 2 in the regions 0 less than mod z less than 1, 1 less than mod z less than 2, mod z greater than 2. So here also we need to factorize the denominator, then separate the fractions by using the partial fraction. So therefore that f of z will be equal to 1 divided by z into z minus 1, z minus 2. These two are the factors of this quadratic equation. Then a by z, b by z minus 1, c by z minus 2. So here the values of a, b, c are a equal to 1 by 2, b equal to minus 1 and c equal to 1 by 2. So therefore f of z, a by z is there, a equal to 1 by 2, so therefore 1 by 2 z, b equal to minus 1, that is minus 1 divided by z minus 1, and c equal to 1 by 2, so therefore it is 1 divided by 2 into z minus 2. Now consider the regions and expand the function in the corresponding region. Now the first is 0 less than mod z less than 1, or it implies that mod z less than 1. So whenever z is less than some constant, we need to take that constant outside from the factor. So 1 by 2z as it is, minus 1 divided by z minus 1 plus 1 divided by 2 into z minus 2. So here this is equal to 1 by 2z. Here greater thing is constant value. So here the constant is minus 1. So therefore 1 minus z plus 1 divided by 2 into, here constant is minus 2. So minus 2 into 1 minus z by 2. Therefore it is 1 by 2z, minus into minus becomes plus 1 minus z whole power minus 1. Here plus into minus, that is minus 1 by 4, 1 minus z by 2 whole power minus 1. So here we have brought these two factors to the numerator. Then this is 1 by 2z plus summation over n equal to 0 to infinity z power n minus 1 by 4 into summation over n equal to 0 to infinity z by 2 whole power n. In both the terms it is 1 minus x whole power minus 1. So that's why I am not writing that minus 1 whole power n. And the second region. So here the second region is 1 less than mod z less than 2, that is 1 less than mod z and mod z less than 2. So means whenever 1 is present in the term, take that z outside, and whenever 2 is present, 2 outside. So therefore f of z equal to 1 by 2z minus 1 by z minus 1 plus 1 by 2 into z minus 2. So 1 by 2z minus 1 divided by, here z is greater, so therefore z into 1 minus 1 by z plus 2 is greater, the 2 into minus 2, 1 minus z by 2. Then it is equal to 1 by 2z minus 1 by z into minus 1 by z whole power minus 1 minus 1 by 4 into 1 minus z by 2 whole power minus 1. That is 1 by 2z minus 1 by z. Here summation over n equal to 0 to infinity 1 by z whole power n minus 1 by 4 summation over n equal to 0 to infinity z by 2 whole power n. So it is the expansion for the second region. And for the third region, that is C mod z greater than 2, or it implies that 2 less than mod z. So therefore here we need to take that z common from each factor. So it is 1 by 2z minus 1 by z minus 1 plus 1 by 2 into z minus 2. So 1 by 2z minus z common, then z into 1 minus 1 by z plus 1 by 2z into 1 divided by 1 minus 2 by z by taking z common from each factor. Then this is equal to 1 by 2z minus 1 by z into 1 minus 1 by z whole power minus 1 plus 1 by 2z into 1 minus 2 by z whole power minus 1. That is 1 by 2z minus 1 by z into summation over n equal to 0 to infinity 1 by z whole power n plus 1 by 2z into summation over n equal to 0 to infinity 2 by z whole power n. So this is the expansion in the third region. So therefore these are the examples on the expansion of Taylor and Lorentz series. So now let us take some assignment questions on these expansions. So here these are the questions. Expand 4z plus 3 divided by z into z minus 3 z plus 2 in the regions 0 less than mod z less than 1, 2 less than mod z less than 3, mod z greater than 3, and f of z equal to 1 by z square minus 4 z plus 1. So z square minus 4 can be written as z plus 2 into z minus 2 and z plus 1 as it is. So therefore apply the partial fraction and separate the fractions, then expand that in the series only one region is given, 1 less than mod z less than 2, and then 1 divided by z minus 1 into z plus 3. Here the region is 0 less than mod z less than 4. The third one, f of z equal to z minus 2 into z plus 2 divided by z plus 1 into z plus 4. So here this fraction is improper fraction, because in numerator also we can get z square and here also z square by after multiplying. So therefore whenever the powers of the variable are same in both numerator and denominator, that fraction is an improper fraction. So therefore first reduce the fraction into improper. So already I have solved one example how to reduce that improper to a proper fraction. So therefore reduce this first to the proper fraction and then solve. In the regions mod z less than 1, 1 less than mod z less than 4, mod z greater than 4, and the third one is 1 divided by z square minus z minus 2 in the region 1 less than mod z less than 2. So factorize the denominator, then apply the partial fraction and then expand that function in the given region. So these are the assignments questions. So here solve these questions and upload the solutions in the Google Classroom as early as possible.